So we are responsible for creating a circus act. We're going to do the human cannonball. So we're going to call this the human cannonball. And we're going to have to set up the net. And we want the net to be at least 3 meters above the ground for great type of, that's what we want it to be. So this is going to be 3 meters above where this arc would be. So if I'm looking at my arc and I'm thinking about our projectile motion, what we're wanting to do is we're wanting to design this so my projectile motion is going to be 3 meters above the ground. Okay, so that's what we're after. We know, because we've been given the specifications for our cannon, that when the person leaves the cannon, they're going to be traveling at 25 meters per second at an angle of 30 degrees above the horizontal. We want to make sure they hit the net, so we need to figure out our range of where we're going to want to be. So a couple things that we want to do. We want to look at our X components of motion and our Y components of motion. So we know that what happens in our X is, in projectile motion, our acceleration in the X direction is equal to 0. Because we're using constant acceleration, and after I leave the cannon, there is no acceleration in the X direction. But we do know we have gravity in the Y direction. So we do have our gravity. So my equations that I'm going to have is I'm going to have my range is going to equal my initial velocity in the X direction times whatever time I'm going to be at. Now my Y components are a little different. Okay, my Y components, I can have velocity final in the Y direction is equal to velocity initial in the Y direction minus gravity times time. I can have my final velocity in the Y direction squared is equal to my initial velocity in the Y direction squared minus 2 times gravity times my change in height. And then I can have my change in height is equal to my initial velocity in the Y direction times time minus 1/2 gravity times time squared. So one of the first things I want to do when I'm doing these problems is I want to find out what my V initial X is and what my V initial Y is. So if I have my vector, that is this is my 25 meters per second vector. And I'm actually going to do this in a different color so that you can actually see a different color. I'm going to have my vector component in the X direction, and I'm going to have a vector component in the Y direction. And this is my angle. So there's my angle of 30 degrees. So the X component is going to be the cosine of the angle is equal to the adjacent side divided by the hypotenuse. And there's my hypotenuse. Cosine of my angle is equal to my adjacent side. So now I'm going to have 25 meters per second. Cosine of 30 is going to equal my initial component in the X direction. So if I do that, this is going to be 21.65 meters per second. Now my Y is going to be sine of the angle, which is going to be my hypotenuse, or my opposite divided by my hypotenuse. So I'm solving for the opposite. So now if I do that, I'm going to have my 25 meters per second sine of 30 degrees, that's going to equal 12.5 meters per second. So we're still trying to figure this out. I don't know the range and I don't know time. Well, that's all well and good, but I have two equations, two unknowns. Because I want to know when my change in y is equal to 3 meters. So if I look at this equation right here, we can set that up. So I'm going to have 3 meters is equal to 12.5 meters per second times time minus 1/2 9.81 meters per second squared times time squared. I can rewrite this, right? I can rewrite this so that I get I get 4.905 t squared minus 12.5 t plus 3 is equal to 0. I can use my quadratic equation. All of a sudden I can't seem to spell. And if I'm using my quadratic equation, it's minus b plus or minus the square root of b squared minus 4ac all divided by 2a. This was making sure I had all my negatives and positives right because it's late in the day. So I'm going to have my 4.905 is equal to a. My negative 12.5 is equal to b. And 3 is equal to c. So I'm going to have minus 12.5 plus or minus the square root of negative 12.5 squared minus 4.905, 3, all divided by 2a, which is 4.905. So I'm going to have 12.5 plus or minus the square root and I have this as 97.39 divided by 9.81. So I'm going to get 12.5 plus or minus 9.87 divided by 9.81. So that gives me a value of I get 0.268 seconds or 2.28 seconds. So if I'm looking at, to understand those values, I need to look at my arc. Remember, my arc is going to go like this. So that first time of 0.28 seconds, that's when it's going to be 3 meters on this end. So that's not the value we're going to want to do to figure out our range. We want to use the other value. We want to use the 2.28 seconds. And that's how we're going to calculate our range. And so our range is going to be our 21.65 meters per second times our 2.28 seconds. And I'm going to put this net at 49.4 meters away from my cannon, so that I'm going to catch the person at 3 meters above the horizontal. Now, I think you guys have a homework problem that does something like this. So we have somebody coming off of a jump. Okay, they're going to come off of a jump, and we're told that this angle, we're going to make it 20 degrees. But we're told that the distance traveled in the x direction is equal to like 100 meters. And then we're also told that the distance traveled in the y direction, we'll say, is 150 meters. Well, I know that distance is going to equal my initial velocity in the x direction times time. I'm given that kind of a value. I think the problem may give you time. I'm not 100% sure, but you're going to have to come up with time. But you can figure out time, right? You can figure out time, because my time, it's going to be my change in y is equal to my initial velocity in the y direction times time minus 1/2 gt squared. And when I do this, my velocity in the x direction is going to be my overall velocity cosine 20 degrees. My velocity in the y direction is my overall velocity sine 20 degrees. That velocity is going to be the same in both my x and y components. So that should sort of help you with that particular homework problem. Give yourself a chance to ponder that and get yourself set up. Similarly, you might have a homework problem that works like this. We're given that we have a rocket that's taking off at a 45-degree angle. We're told that its acceleration for this time period is 5 meters per second squared. We're told that it's 2.5 seconds. And after this point, we're told that it's going to travel by projectile motion. So what you do in these cases is you break it up into parts. So this is a one-dimensional motion problem. This part of the problem is a two-dimensional motion, projectile motion problem. All we've done is add the two components together. So what I want to do here is I want to find the velocity at this point, because that's what I want to find. Well, that's easy enough. We know that velocity final is equal to velocity initial plus my acceleration times time. So my velocity final is going to equal, this was 0 because we started from 0. I was told that we're going 5 meters per second squared, and we're going to do this for 2.5 seconds. So if I do 5 times 2.5, this is actually going to be at 12.5 meters per second. And that's going to be our initial velocity at this part. I'm going to have 12.5 meters per second at a 45-degree angle. So I can calculate my V initial X. Well, that's 12.5 cosine of 45 degrees. And my V initial Y, which is 12.5 sine of 45 degrees. And now I can work this problem just like my Cannon problem. So we break it up into 2 parts and we look at how the problem gets started. So that should give you some help on that homework problem as you get into there. I've got a message in the chat, so give me a second. Which page? You couldn't see it. This page? Because I think I was in the middle of the page on everything else. All right, so you got it on that side. All right, any other questions on projectile motion? All right, see.